Okay, so for this lecture, we will look into the naive Bayes classifier. So this is normally used when you have a non-deterministic problem in which you can use the probability in order to classify record that you have. Okay, so so the name of the classifier is called Bayesian classifier. So basically, when we have um, a new item, so for example, we have this new test record. This. So we will look into the probability. What is the probability of having this new item with the class membership from different classes? So we will have we will compute the probability of having this in the same class as the previous record that we have. So for the Bayesian classifier, and this is a statistical classifier in which we perform probabilistic prediction. We predict class membership probabilities. So this is the easiest one because we just use the counting procedure. So the foundation of this Bayesian classifier will be based on the Bayes theorem. So we will revisit again this theorem. The basic assumption is that the class are mutually exclusive. Mutually exclusive meaning that two events cannot happen at the same time. Okay, and we have list all the possible combination of event that can occur during that time. And we also assume that the attributes are independent given the class. So meaning that all the attributes that we have will be assumed to be independent. Okay? So they are called naive classifier because of this assumption, and they are empirically proven to be useful and scales very well. Okay, so scales very well means that it could also be used for large database, large data sets. Okay, so like I mentioned just now, in many applications where the relationship between the attribute set and also the class variable is non-deterministic, so we can use the probabilistic approach. So the Bayesian classifier is an approach for modeling probabilistic relation between the attribute set and the class variable. So the attribute set is all the um, independent variable, and then the class variable will be the dependent variable. Okay, so you may have a few attributes, and then you only have one class variable. Okay, so more precisely, Bayesian classifier use Bayes theorem. So we will look into this one. So for that reason, we will look into the theory of probability first, and then we go to the Bayes theorem. Okay. Okay. The first definition. The first definition called simple probability. If there are n elements, no, n elementary events associated with a random experiment, and m of n. So m of n of them are favorable to an event A, then the probability of happening or occurrence of A is this. Okay. Okay. What is the probability today is Wednesday? Can you answer that one? The probability of having today is Wednesday. Can someone answer that one? What is the probability of having today is Wednesday? Someone can answer. How many days we have in one day, in 1 week? How many days we have? 7. Okay. So the probability of having today is Wednesday will be 1/7. Okay. Okay. What is the probability of tossing a head, tossing a coin and having a head? How many possibility we have for the coins, head and tail? So 1/2. Okay. So in our class we have 36 students. What is the probability of you being picked as the best student? So in the class we have how many students? We have 36. So what is the probability of having you to be selected as best student? 1. Yeah? Okay. So this is a simple probability in which we count the number of all the possible outcome, and this is um, the event that occur having the characteristic that you have mentioned in your value here. Okay. So suppose A and B are two events. So we have probability of A and also probability of B. Denote the probability of the event A and B. So when we talk about the mutually exclusive event, is that the two evo- two event cannot occur at the same time. Okay, so for example, like this, the first one is tossing a coin and proceed with the tossing a Ludo cube. Okay, so they come after the previous event has occurred. Okay, um, can you give an example so that two events are not mutually exclusive? So meaning that they can occur at the same time. Okay? So the hint here is that tossing two identical coin, and also the weather is sunny, foggy, and warm. So the weather could be sunny and also warm. Um, Tossing two identical coins, so this thing can happen at the same time. Okay, so these are not mutually exclusive events. So when we talk about mutually exclusive event, is that um, the next event occur right after the previous event has occurred. Okay, when we talk about independent event also, two events are independent if occurrence of one does not alter the occurrence of other. So they are two independent. There are no relation between the first and the second one. Okay. Okay, the second definition is the joint probability. So the joint probability of two event A and B can be defined as this, in which we add the probability of A and the probability of B minus that they occur at the same time. Okay. Okay. So if A and B are mutually exclusive, then this one will be 0 because we are saying that there are no intersection. They occur after the first event occurred. Okay, so this one will become 0. Okay, and if A and B are independent, then um, the intersection between A and B should be the probability of A times probability of B. Okay, so based on this, we can assume that this can be simplified to this because this one will become 0. So that's the mutually exclusive event. This is the formula that we get. Okay. Okay. We also have the conditional probability. So if events are dependent, then their probability is expressed by conditional probability. The probability that A occur given that B is denoted by this. So given B, what is the probability of having A? Okay. So when we look at when we try to count our data, so basically we list out all the number of events in B, and then we at the top here we count number of event in B which favorable to A. So when we translate them into this symbol, so basically we are looking at the intersection of A and B, and the bottom here will be B. Okay? So these are the basic foundation for the conditional probability. Okay. Any question? Okay. So we are here now. Okay. If you okay, can you type number 3? Okay, good. Okay, so this is what we get. Given event A, given event B, what is the probability of having A? So this is the um, formula that we have from the previous example. So basically, we are dividing the A intersect with B by the probability of B. So these two are the same. Okay. So if we interchange A and B, we will get similar like this. Okay. So what we wanted to do is we want to simplify this. Okay. So since we are saying that they are the same, so basically we want to replace this one or replace this one. So when we move this one to the other side, then we get the value of this. So then we get this one lah. So this is come from here, where the probability of having A and B is equal to the dot product of probability A times probability of given A and B. Okay, so we simplify that one using that one. So, and at the same time also by the law of total probability, we are talking about this one. Um, Basically, we are combining the probability of um, having even A and also not even A. Okay, so this is the total probability of B. So that one can be substituted here lah. So basically we have this. Okay, and then when we expand this, we can get this as there are two because this is union. Okay, plus, and this is we are using the same formula here in order to expand this. Okay. Okay. So when we talk about the total probability here, we are basically looking at this definition. So in the total probability, let E1 up to En be mutually exclusive and exhaustive event associated with a random experiment. So if A is any event which occur with E1 up to E1 or E2 or and so on. So basically we are using the plus here, and then we are looking at the event 1 for having A, and then the probability of having A given event 1 in A. Okay, and this is the probability of E1. So we will add up all the value here, and we get the total probability of um, event A in all the E1, E2, and En. Okay. Okay. Now we look at some example. In this example, we have a bag containing 4 reds and 3 black balls. So basically, we have 7. Okay. And in the second bag, we also have 2 red and 4 black balls. So we have 6. So in the first one, 1, and this is 2, and then we have 4 red here, and then black 3, and over here we have 2 red and 4 black. Okay, so um, the situation is one bag is selected at random. So this is the first event. From the selected bag, one ball is drawn. So this is the second event. So what is the probability that the ball is drawn red? So this problem can be answered using the concept of total probability. So we are looking at the probability of drawing the red ball. So basically we are looking at the first event. So the first event is selecting big one, and the second event is selecting big two. So we just plus them lah. Okay. So this one say that given that you are in a big one, what is the probability of drawing red ball? Okay. And this one also given that you are selecting the big two, what is the probability of drawing red ball? Okay. So we can compute this. Okay. Um, there is another example, reverse probability. Okay. In this case, we have the same big one and big two. So you have chosen one ball at random, and it is found that the ball is red. So what is the probability that the ball is chosen from bag one? So this is in reverse. Huh? So the given that you have drawn the red ball, what is the probability of having you selected the bag one here? Okay. So for that one, we are using the Bayes theorem probability. Okay. So the Bayes theorem probability is saying that let E1, E2, En be n mutually exclusive and exhaustive event associated with a random experiment. So if A is any event which occur with E1 or E2 or En, then we have this is the total probability. Okay, so basically we are looking at here. Given that you have even A, what is the probability that occur in this environment? Okay, so remember that this is your total probability, and this is the um, given that you are in this environment, what is the probability of having A? Okay, so this is the formula that we will be using for your bias theorem. Okay, um, before we can look at the actual example, let's take a look at this one, prior and posterior probability. So let's suppose this is your event lah. This is your event, and this is your class. Okay, so we are saying that the probability of having y equal to a will be 1, 2, 3, 4, 5. So we have 0.5. Okay, so let's suppose that given the value y is a, what is the probability of having x2? So x2 we have 1 and 2. So basically, if you want to count the probability of having x equal to x2, given that y is a, is basically 2 over 5, so zero point 0.4. So this is the technique that we will be using when we wanted to compute the classification using the bias theorem. Okay. Okay. In a naive Bayes classifier, suppose y is a class variable and x is a set of attributes. So this is your class and this is your set of input. Okay, the classification problem then can be expressed as the class conditional probability. So basically we are looking at all the attributes that we have. Okay, so this one referring to your attribute, and this is the class. So basically we are saying that given the value of all your attribute here, what is the probability of having class y here? Okay, okay, so basically this is your foundation. Okay, given all the attribute that you have in your data set, what is the probability of having class y? So this is the formula that we have obtained before. So we just apply this one lah. So this one is the total probability of having x. So basically we are computing the total probability of having all the attribute x, and also the um, this one is simply finding the given class y, what is the probability of having this value. So this is done here. This is the example that we have. No, this one. Okay, and this is just simply finding the classification that we have for this class. So this case 1 and case 2 will be applied in here. This is case 1 and case 2. Okay. In most cases, you don't have to compute this one because they are, when we try to get compare two possibilities, the bottom here will be the same. Okay, let's go for the example. But this is how we decide the classification. suppose that we have a given instance of X, so a given record that containing X attribute. So there are two class conditional probability. So whether they belong to yi or yj. So we will given the attribute X here, we wanted to compute the probability of the class of y1 and yi and yj. So whichever is bigger, then we decide that one will be the class of the new item. So whichever is bigger, then we say that this class is belong to that particular instance. Okay. So let's take a look at this example. Okay, in this example, we have this class. So the probability of class one will be yes. So how many yes we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability of the probability of C1 will be how many? 3, 3, 9 kan? 3, 3, 9 over how many we have? 3, 3, 4, 14. Okay. And then the probability of having class 2 will be 5 over 14. Kan? Okay, now we have a new data. Okay, new data saying that the age is less than 30, income is medium, student, yes, they are student, and then the credit rating is fair. Okay, so we want to classify this one whether they want to buy computer or not buy computer. So how do we perform the calculation? Okay, so like I mentioned just now, the probability of buy computer yes will be 9 over 14 because we have yes 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 over 14 because we have 14 records here. And the remaining will be 5 lah. Okay, so given that, okay, in this case, we are looking at, given that the class is CI, what is the probability of having the attribute X value? So for the buy here, for the age 30, so for the yes, this is no. We have 1, 2, only 2. Okay, so that's why we get 2 over 9. Okay, so we only have 9 number of nila. Okay, when we looking at no, not by computer, so 5, so not by, we have 1, 2, 3. Okay, 3, so we have 3. Okay, so that is the probability of having age less than or equal to 30, given that they are not buying computer. So we can compute the rest of them here. Then the final probability will be this one, because the X value is this, all the value for your attribute. Okay, and we wanted to compute this value and also this value, because this is the value that we have for each of the class. Okay, so this is the, let me go back to the example here. Okay, so basically this is the, let me erase. So basically this is what we wanted to compute. Okay, so if we carry that one back here, so basically we are computing this one. We did not compute the total probability at the bottom there because they are the same for both cases. Okay, so when we compute this one, we will have um, this one is higher than the second class. So therefore, we can conclude that X belong to the class where the computer is yes. Okay, so you need to go over this how to get all this value, and then you just plug in the value here lah. Okay, let me give you another example. Okay, so given that we have this is just to give you the some of the calculation, the basic calculation that you need to have. So the first one will be you need to count the probability of having each of the class that you have in your dependent variable. So since we only have two, so yes is how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes is 9 over 14, and then no is 5 over 14. Okay. Um, so for this one, given the attribute A, no, given the class that you have, what is the probability of having this attribute? So contohnya macam ni ya. So given that the play is no, what is the probability of having sunny? So we look at this example again. So play, we are looking at play no. Okay, so we have 1, 2, 3, 4, 5. So we have 5 possibility. And then what is the probability of having outlook is sunny? So we just 1, 2, 3. Oh, so only 3. Okay. Okay, if we have another example here, play yes. So play yes, we have how many yes? 9 kan? Okay. So for the 9 yeses, we have this. And then we are looking at the temperature is mild. Temperature is mild. So 1, 2, 3, 4. So only 4. Okay, so 4 over 9 lah. So the rest are the same. Okay, so in the exam, they will ask you something like this. Given today is sunny, mild, humidity is normal, and windy, should we play or not? So this is your dependent variable. And your x will be all this value lah. Okay, so what we wanted to do is we want to compute the probability of yes or no given x here. So first we compute the probability of playing is yes given the x here. And soon next you also have to look at the probability of play no given x here. So whichever is greater, you will decide the class to be that class lah. Okay, so for example like this, given the x here, we compute the probability of play yes. So basically, okay, this one we can ignore, and basically we are computing all this lah. Okay. Over here, we assume they are independent, so that's why we can separate them. So this is for the sunny times the mile times the normal one times the windy is true, and then times the probability of yes, which is this one. No? Okay. So all this can be computed manually, and you get this. Okay. So 0.014. We don't have to compute this one because for the next computation it will be the same. So we just compare the value here only. Okay. So if we compute for the no, so the value is 0.010. So it means that this one is that means we play because we have higher probability. Okay. So this is how we um, conclude. This is how we classify. Okay. A very brief one. So this is like recalling your probability knowledge, and you just apply them to perform the naive Bayes classifier. Okay. Any question? If you're okay, can you type number 5? I have also extended the due date for the assignment since we covered this one a bit late.